The measurement crisis. The Qwen team just published a paper confirming what an independent researcher discovered weeks ago while debugging a DeepSeek overclock experiment. The gold standard labels in both GPQA and HLE Humanities last exam are riddled with errors. The original investigation found DeepSeek rigorously deriving technically correct answers that contradicted the provided labels. And when the math was verified line by line from first principles, the model was right and the benchmark was wrong. Qwen's paper doesn't mince words. Many HLE questions are fundamentally broken, and some standard answers are simply incorrect. This matters because GPQA and HLE aren't obscure test suites. They're the benchmarks labs cite to claim frontier progress. If the ground truth is corrupt, leaderboard deltas between models may reflect noise rather than genuine capability differences. The problem compounds when you remember the benchmaxing dynamic. Models optimized for harness formats until those formats become baked-in defaults, hallucinating box latex answer formatting that appeared nowhere in their prompts. We've now gone from models gaming the test to the test itself being wrong. A qualitatively different failure mode that calls into question the entire evaluation pipeline from dataset curation through scoring. The gap between benchmark scores and real-world performance shows up vividly in a new independent evaluation of Qwen 3.5, the Apex testing benchmark. 70 tasks drawn from real GitHub repos, covering bug fixes, refactors, race conditions, and CLI tool builds, found that Qwen 3.5 397B craters on master difficulty tasks, dropping from a respectable about 1550 ELO on hard/expert work to 1194 when coordination across many files over many steps is required. The model simply loses track of what it's doing. Meanwhile, GLM 4.7 quantized at about 205 GB still beats every Qwen 3.5 variant, including the full 397B cloud version, posting 1572 ELO. One Qwen model even found a loophole. QWEN3. .527B ran a test suite, saw existing tests passing, declared everything already implemented, and quit without writing a single line of code. It was the only model out of 25 plus that tried this. On a brighter note, Codex 5.3 is basically tied with GPT 5.2 at number 4 overall, showing remarkable consistency across difficulty levels. The trust problem extends beyond benchmarks into the information supply chain itself. A new report from The Verge reveals that ChatGPT, Gemini, Copilot, and Perplexity are increasingly citing Grokipedia, Elon Musk's AI-generated Wikipedia alternative. As a factual reference, Grokipedia faces heavy criticism for hallucinations, plagiarism, and promoting debunked conspiracy theories. The result is a circular AI-citing AI loop, where one system's hallucinations become another system's source material, a feedback mechanism that could systematically amplify misinformation at scale. Architecture frontiers. Deeper reasoning, cheaper inference. 3 papers this week attack different bottlenecks in transformer efficiency, and together they sketch the outlines of a post-attention era architecture. The common thread: fixed depth, quadratic cost computation is the real ceiling, and the most promising paths forward involve rethinking how information flows rather than simply adding more parameters. The most striking result comes from TurboConn, which introduces TurboConn, an architectural modification that routes residual connections from higher layer hidden states of each token back to lower layers processing the next token. The insight: reasoning power in standard transformers is fundamentally bottlenecked by fixed depth. TurboConn breaks this by allowing effective reasoning depth to scale linearly with sequence length, rather than being capped by layer count. Fine-tuning Qwen 3.1.7b with TurboConn achieves 100% accuracy on parity tasks where standard fine-tuning plateaus at 53.78%, and the modified 1B model outperforms the 8B baseline, demonstrating that improved information flow can surpass raw parameter scaling for certain reasoning problems. Critically, dense multi-layer to multi-layer connections significantly outperform sparse alternatives like passing only the top layer hidden state back to the input. The model also exhibits strong length generalization, maintaining perfect accuracy on sequences 3x longer than training data, suggesting it learns generalizable algorithms rather than memorizing patterns. On the inference cost side, Noesis Labs' Spartacus 1B proposes a more radical departure. It completely replaces softmax attention with causal monoid state compression, compressing the entire causal prefix into a fixed-size debyte state matrix that updates via a single monoid operation per token. The result is true O1 inference time and O1 memory per token. Whether generating the 10th or 100,000th token, the cost stays constant. Learned content-dependent vector decay gates replace both rope and attention masks, with fast decaying dimensions tracking local syntax and slow decaying dimensions serving as global memory. At 1.3b parameters, Spartacus outperforms Mamba 1.4, B and R, W, K, V. 6. 1.6, B on zero-shot ARC benchmarks, and integration of structured chain-of-thought data has pushed reasoning accuracy to 75%. The architecture is theoretically elegant, though community commenters rightly note that benchmarking against Mamba and RW rather than current subquadratic SOTA like Kimilinear or Qwen 3 Next leaves the competitive picture incomplete. Meanwhile, a team from MBZUA, Isvila Lab challenges a long-held assumption in model compression. Sync-aware pruning for diffusion language models demonstrates that attention sinks. Token positions absorbing disproportionate attention mass behave fundamentally differently in diffusion language models DLMs compared to autoregressive models. In AR models like LMA3, sinks are spatially concentrated on fixed early tokens and remain temporally stable throughout generation. In DLMs like LLDA and Dream, sync positions shift substantially across denoising time steps, with temporal variance orders of magnitude larger than in AR models. The standard pruning heuristic of always preserving sync tokens, inherited wholesale from AR research, actively hurts DLM compression. Their proposed method, which computes soft sync scores and downweights unstable positions before feeding activations into existing pruning criteria, consistently outperforms baselines at 5.075% sparsity levels with no retraining required.
Silicon gets specialized. Thales, the startup that emerged from stealth with over $200 million in funding and a radical proposition, etch model weights directly into transistors, has opened free access to its first-generation ASIC running Llama 3.18B at 16,000 tokens per second. The HC1 chip, fabricated at TSMC 6 nanometers with 53 billion transistors on an 815 square millimeters die, uses mask ROM recall fabric and SRAM KV caches rather than general-purpose compute. At roughly 200 W power draw, napkin math puts the cost at about $0.005 per million tokens for electricity alone. The chatbot demo undersells the speed. Anything over a few hundred talks/s feels instantaneous. But the real showcase would be token-intensive API workloads where that throughput translates into radically different economics. The obvious limitation: every model revision requires a new mask spin, with a reported 2-month turnaround. Thales is betting that a few dominant model sizes will see enough production volume to justify application-specific silicon, the diametric opposite of Tenstorrent's general-purpose programmable approach. On the other end of the hardware spectrum, Cognitum has announced what it calls the world's first agentic processing unit, a proportional intelligence system designed for always-on, event-driven, ultra-low-power agent workloads. Details remain sparse. It's positioned as neither a GPU box nor an edge server, but as intelligence that lives, suggesting purpose-built hardware for persistent agent loops rather than batch inference. The infrastructure conversation took a less inspiring turn with Hetzner announcing 3.040% price increases effective April 1st, 2026, applying to both new orders and existing products. Server auction machines get a 3% bump. Hetzner has long been the budget-conscious self-hoster's favorite, and just months ago was lowering prices and expanding flexible options. This reversal changes the calculus for anyone running inference, crawlers, or multi-agent systems on their metal. The broader trend is unmistakable. The era of artificially low cloud pricing, fueled by competitive pressure and massive capital investment, is giving way to economic reality. Agent security, the full defensive stack. The security engineer behind Clocker puts the problem bluntly. Handing an LLM unrestricted code execution, network access, and full file system access is reckless, and Claude Code's built-in sandbox is the Temu version of a container. Clocker is an open-source Go tool that orchestrates Claude Code agents inside Docker containers with security defaults that would make a paranoid sysadmin smile. A network firewall restricting outbound traffic to GitHub and package managers, a PKG/W, HAI, LJL preventing containers from seeing non-Clocker Docker resources, project-based namespace isolation, and seamless Git credential forwarding via host proxy service. The convenience features are equally thoughtful. An embedded parameterized Dockerfile template with an unprivileged Claude user, Git worktree integration for parallel development on separate branches, an optional Prometheus/Loki/Grafana monitoring stack, and an experimental looping mode that runs autonomous agent iterations with stagnation detection and circuit breakers. It's the harness for the harness. Containment without detection is half a solution. Canary brings the honeypot token principle, which has worked in traditional security for 15 years, to LLM and RAG applications. The approach is simple. Inject synthetic fake credential stripe keys, AWS keys, credit cards into an agent's context, then scan every output for exact token matches. If a canary appears in output, it's definitionally a breach. 0 false positives, no probability thresholds, no tuning. The library wraps LLM calls with automatic scanning, reporting 6 ms detection latency. The prior art here is Beelzebub's canary tools for MCP, which registered fake functions like repo exfil that trigger alerts when invoked. Canary extends the concept from tool invocation to the output stream itself, catching exfiltration that looks exactly like a normal agent response. The supply chain perspective rounds out the defensive picture. A pointed editorial argues that replacing open-source dependencies wholesale with AI-generated code confuses technical viability with enterprise reality. CVEs are actually good, the author contends. A known vulnerability is infinitely better than an unknown one, and the generate test reprompt loop for AI replacements isn't free. Google's Project Zero, Anthropic, and others keep finding critical flaws in mature software using AI as a discovery amplifier, which benefits the entire ecosystem, including packages already in your stack. The real shift for AppSec practitioners is toward managing guardrails around AI-assisted development, not pretending the dependency toolchain vanished overnight. The identity layer of this stack reveals trade-offs that would make a CCSO wince. A forensic teardown of LinkedIn's identity verification exposes what a 3-minute passport scan actually costs. And the answer is far more than you'd expect for a blue checkmark on a professional networking site. The process is handled not by LinkedIn, but by Persona Identities, Inc., which collects full biometric faceprints, NFC chip data, behavioral biometrics keystroke timing, interaction pauses, and cross-references users against credit agencies and government databases. All 16 subprocessors are US-based. The Cloud Act means a US court can compel disclosure regardless of where the data sits physically. Frankfurt server or not. Persona's liability cap for a breach exposing your passport, facial geometry, and national ID number, $50. The agent orchestration stack. The 100x developer claim has evolved from Twitter boasting to documented infrastructure, and the details are more interesting than the headline number. Brandon Cashy walks through the progression from using Claude Code for individual tasks to building a full orchestration layer that triggers agents via GitHub webhooks. The early months were trial and error, figuring out what Claude Code could actually handle versus what I still needed to do myself. Each improvement compounded. Better documentation led to better agent output, which built confidence to delegate more. The bottleneck wasn't the agents or the code. It was the human directing everything manually. His solution turns GitHub issues into work orders with 2 labels. Agent spec expands a casual description into a full implementation spec using project context, while agent implement executes it. Writing code, running tests, committing, and opening PRs. A write/review agent loop iterates until standards are met, with a circuit breaker to prevent infinite loops. The proof point. On a single day, 2 agents across 2 codebases resolved a production disk-full crisis. One forked and upgraded a Ruby gem, while another updated the Rails app through 4 iterative Dockerfile debugging attempts. Cache doesn't take 100x, literally, but frames the gains as fundamentally operational, rather than about typing speed. The tools enabling this kind of workflow are proliferating. Santiago Valderrama demonstrates a Claude Code skill using Nimble to pull live, structured data from any website. Not returning a wall of text, but normalized tables organized by schema, handling JavaScript-rendered content. On the local first side, local agent v0.1. One provides an agent runtime supporting LM Studio, Alama, and Llama.c, PP backends with Playwright MCP for browser automation, tool calling with safe defaults shell and write disabled by default, replayable run artifacts, and an eval harness for repeatable testing. The safety-first posture. Explicit flags required for coding tools, approval policies, and trust controls. Contrasts sharply with the dangerously skip permissions defaults that Clocker was built to contain. The context layer is where things get architecturally ambitious. Context Graph tackles the memory problem with a 13-embedder MCP server that embeds every memory simultaneously across semantic, causal, temporal, code, entity, and structural spaces, then fuses results using reciprocal rank fusion. 3 embedders maintain dual vector indexes for asymmetric queries. What caused X, and what did X cause, return different results. The system exposes 56 MCP tools, covering everything from causal chain building to entity extraction with trans predictions, backed by RocksDB with 51 column families and 15 HNSW indexes. It targets sub-5 milliseconds P95 latency for storage. Meanwhile, Starlog offers curated deep dives on offensive security tools and AI agents, indexing GitHub stars into actionable intel for security professionals and agent builders. A recognition that the observability layer for this ecosystem barely exists yet. Local AI and the self-hosted stack. Hugging Face and Unsloth have teamed up to offer free model training through HF Jobs, with Unsloth providing about 2x faster training and about 60% less VRAM usage. The target is LFM2.51.2b Instruct, a sub-1 GB model optimized for on-device deployment on CPUs, phones, and laptops. A Claude Code or Codex skill handles the entire pipeline, generating a UV script with inline dependencies, submitting to HF Jobs, and pushing the trained model to your hub repo. The barrier to entry for fine-tuning has essentially collapsed to ask your coding agent to train a model, though the guidance wisely notes you should ask for cost estimates before launching large jobs. The definition of local keeps expanding. Kitten TTSV 0.8 now runs entirely client-side in a minimal next.js app, with nano/micro/mini models fetched from Hugging Face and cached via the Origin private file system. It depends on Runtime Web and Xenova's .js, though it's currently limited to the WASM backend web GPU outputs silence and doesn't work in Safari. The trajectory from server-dependent TTS to fully client-side synthesis in a browser tab represents a genuine shift in what local inference means. No install, no Docker, no GPU. For those who prefer their AI stack on real metal, one project packages LightLM Unified API Proxy across providers, N8N workflow automation, and OpenWebY into a single Docker Compose file. It's the everything bagel approach. Individually well-known components wired together into a turnkey local deployment that handles multi-provider routing, visual automation, and a chat interface in one Docker Compose up. And when your AI workloads outgrow a single Postgres instance, PGDog offers a Rust-built proxy that adds transparent sharding, connection pooling, and load balancing without changing application code. Unlike pgbouncer, pgudog parses SQL using PostgreSQL's native parser pgquery to route reads to replicas and writes to the primary through a single endpoint, correctly handling set statements and session parameters that trip up simpler proxies. It handles cross-shard queries by fanning out to all shards and assembling results in memory, supports two-phase commit for atomic cross-shard writes, and can reshard databases online using logical replication with zero downtime. No XED, no Zookeeper, just a toml config and a coordinated cutover sequence. Already used in production at scale, it's a reminder that not all critical infrastructure improvements require AI. Sometimes you just need someone to write a really good proxy in Rust.